Good evening, ladies and gentlemen. It's January 26, 2022. It's good evening here in Los Angeles, California. This will be my second discussion for January 26. I just want to give you an example problem that falls under the trigonometric function that involves secant only, in which the solution could not be solved by simply knowing trigonometric identities. So I will give you a new formula on how to attack that problem. And that formula is actually the so-called integration by parts. Integration by parts. Okay, I will try to derive the formula for integration by parts that will be applicable to a secant only function on trigonometric integrals. We lead differential of u and b. Differential of u and b. Okay? This should be equal to, if we take the differential of u and b, it's a product, right? So it should be the first one times the differential of the second plus the second function b times the differential of the first. Okay? Take the integral of both sides. The integral of the differential of ub equal to the integral of udb, the first one, plus the integral of the second one, which is b du. Actually, we are solving for the integral of udb. We are solving for this. The given problem should be under the form the integral of udb. So, for integration by parts, we are solving for this. Rearranging this to solve for the integral of udb, the integral of udb now equal to the integral of the differential of ub. We will transpose this to the left, then we rearrange, right? Actually, this is the integral of the differential of ub. The integral of the differential of ub. Okay? We place this one to the left, then we rearrange, then we solve for this. The integral of udb, excuse me, equal to the integral of the differential of ub minus the integral of b du. But when the integral sign goes with the differential sign, they will cancel out each other. So this will be removed. So what will come out on the right hand side will just be simply ub. Excuse me. It's ub minus the integral of b du. To solve problems under this form, you must have to compute for u, you compute for b, okay? Then take the integral of b du, just to solve that one. And this formula here is applicable to secant only problem. Because I try to solve one problem under secant only, and only by using our knowledge of trigonometric identities, we could not bring out the answer. So, in addition to attacking that problem, I bring out this integration by parts. Actually, this is another topic, but for the meantime, since we cannot solve the problem secant only by using only trigonometric identities, I brought out this formula here to aid us in solving the problem. Okay, I will try to bring out the problem. Okay? That given problem that I was mentioning was the integral of secant of cube theta, differential theta. it falls under secant only. Right? But for the meantime, the power is 3. The power of secant is 3. It is an odd number. If we try to solve this by using only our knowledge of trigonometric identities, we could not bring out the problem. I will show you later. Okay. Okay, let's proceed. By using this integration by parts. The integral of secant of cube secant to the third theta differential theta can be written as simply the integral of secant theta, secant square of theta, differential theta. And here, I choose that the value of u is this secant of theta here. It's a trial and error. You can choose whichever you want. You can choose secant square of theta to be your u, but later on, if you could not arrive at an answer, you're wrong. So my first assumption here, I will let u equal to secant of theta. Then secant square of theta differential theta, I will place that as dB. Okay? Why dB? It is in this form here. Okay? It seems we are integrating a problem under the form u dB. So I assume that secant of theta is u, and secant square of theta differential theta is dB. Right? Okay. So if I will let u equal to secant of theta, what is du? Oh, take the differential of both sides. The differential of u is just du. The differential of secant of theta, secant is secant tangent, right? So it should be secant theta tangent of theta differential theta. I choose this to be my u, so this will be my du, right? I bring out my du by using my knowledge of differential calculus. For the meantime, I'm not using any identities. Later on, we will use the identities. Because as I told you, without using this, and only if you use the identities, you could not bring out the problem, bring out the solution of the problem. dB. I choose my dB to be secant square of theta differential of theta. dB is secant square of theta differential theta. Solving for b. If you try to solve for b, take the integral of both sides. Right? The integral of the differential of b equal to the integral of secant square of theta differential theta. The integral of the differential of b, this will cancel out. Okay? It is b now. Okay? Equal to, is the right hand side integrable? I think so. Because there is a formula or a function under integral that when we integrate it, what will come out will be secant. If we try to take the differential of tangent, it is secant square of theta, di ba? Right? So the integral of the secant square of theta differential theta is tangent of theta. We are integrating. The integral of secant square of theta differential theta is tangent of theta. Why tangent of theta? If you take the derivative of tangent, it is secant square of theta differential theta. So it's correct, right? So we are now given the value of b. Okay? So if we try to follow this, the integral of u dv now equal to, we follow this formula. That is the formula for taking the integral by using integration by parts. It is ub minus the integral of b du. ub minus the integral of b du. Okay, substituting values. What is u? U is secant of theta. And what is b? It is tangent of theta. Minus the integral of, what's next? What is b? B is tangent of theta. This is b. And what is du? du is secant of theta, tangent of theta, differential theta. It's this. This is b, and this is du. Okay? And this is ub. We are following this formula. The formula for taking the integral of by integration by parts. We are not yet using identities here, I told you. Okay, so UB minus the integral of B du. U is secant of theta, B is tangent of theta, minus the integral of B. What is B? Tangent of theta. And what is du? Secant theta, tangent theta, differential theta. Okay, secant theta, tangent theta equal to there is 1 secant of theta here, right? Then tangent of theta, that will be tangent square of theta. But 1 plus tangent square of theta equal to secant square of theta. This is where the trigonometric solution will come in. Okay? It is this. You replace tangent square by secant square of theta minus 1. Okay? It is this. So what will come out? Secant theta, tangent theta. Secant theta, secant square of theta is secant cube of theta. Differential theta. This is negative. Right? Secant theta times minus 1 is actually this minus is minus, so it will be plus. Secant theta times differential theta. So this will minus, this is minus minus, this will be plus. Secant theta differential theta. Okay? Then I expedite a little bit. I multiply the product of secant theta differential theta by the quantity secant theta plus tangent theta over secant theta plus tangent of theta. Because this is actually 1. We could do that. Okay? That is a part of our solution. Because if I will place secant of theta plus tangent of theta all over this, okay, it seems this is now under the natural logarithm, where the value of u is secant of theta plus tangent of theta. The value of u is the one underneath. Take the derivative of differential of the denominator. The differential of secant is secant tangent, and the differential of tangent is secant square times differential theta. So, if you try to observe this one, it is same as this. Right? So, this now falls under the integral of du over u. Right? That's integrable. This has been integrated. Don't you notice it? This term here is negative the integral of secant cube of theta differential theta. Actually, our left hand side, the one we are solving, is the integral of secant cube of theta differential theta, right? That's the one we are solving. This is negative, okay? We place it on the left, so this will become 2, right? And this is gone, right? So what remains on the right will be secant of theta plus tangent of theta plus the integral of this, and which we now know the solution. This is to be under natural logarithm, okay? This is 2 the integral of secant cube of theta differential theta equal to secant of theta tangent of theta minus the integral of this is the natural logarithm of secant theta plus tangent of theta. This is plus c. But this is 2. And the problem is only asking for the integral of secant of cube theta differential theta. So we multiply all terms by 1/2. Right? So this will cancel out. The left hand side now, the original problem. The integral of secant cube theta differential theta equal to, we multiply 1/2 also the right hand side. So this will become 1/2, open bracket, okay, secant theta tangent of theta plus the natural logarithm of secant theta plus tangent of theta, close bracket, plus c. That's the final answer. You see how we arrive at the solution by using integration by parts and by using our knowledge of trigonometric identities. That's the one I am emphasizing. Without knowing the integration by parts formula, and only if we just apply our knowledge of trigonometric identities, we could not bring out the solution for the integral of secant cube theta differential theta. So, under secant only, for secant cube, to solve this, we apply our knowledge of integration by parts plus trigonometric identities. There come a time we go to the topic integration by parts. Unluckily, for this secant cube, we could not bring out the solution if we just use only the trigonometric identities. Oh, I think this was an interesting discussion because it seems the problem is simple, but if we just use our knowledge of trigonometric identities, we could not solve the problem. So I researched a little bit. I introduced integration by parts. So with the aid of integration by parts, plus our knowledge of trigonometric identities, we were able to bring out the solution for this problem. So the final answer for the integral of secant of cube of theta differential theta equal to 1/2, open bracket, secant theta tangent theta, plus the natural logarithm of secant theta tangent of theta, close bracket, plus c. Oh, that was a good problem. Okay. So the solution is not just only by using trigonometric identities, we introduce integration by parts. But later on, we will go with the topic integration by parts. Unluckily, we need this integration by parts for the meantime to solve these problems. That's why I brought out the formula for taking the integral by integration by parts. That is the integral of UdB equal to UB minus the integral of BDU. Oh, I think that's just more than good enough for tonight. It was a good example, okay? So we are now through with the secant. So the next time around, we will go with the cotangent and cosecant, then cosecant and cotangent exclusively. Okay, we are now through with the sine and cosine combined, sine only, cosine only. We are now through with secant and tangent. We are now through with secant. Okay. I think that's just more than good enough for tonight, ladies and gentlemen. If you like my discussion, please click like. If you want to share it, please click share. And if you want to subscribe to my channel, please click subscribe. Good evening, Los Angeles.